Hello, everyone. Come on in. Just waiting for the rest of the people to come in, and then we'll get started. I'm also setting up my iPad to work appropriately. Not convinced it's going to do that, but we'll see. All right, got more people coming in. All right, so that's working. Hey, see you made it, Shanda. Logan's having some difficulty. I don't know why she hasn't been able to get in yet. I've got 10 of the students. I'm thinking one of my students is showing that they're in the waiting room and trying to join, and it's just like beeping, beeping, beeping. So I'm kind of hoping the student won't be able to get in. Might not be working, but we're going to have to start in a second either way. In case you haven't met me before, I'm Mr. Younger. I teach physics and astronomy here at TCC. I've been here 11, 12 years, something like that. I've been teaching it physics and astronomy and math since probably 1990, maybe 1996, 95, somewhere around there. So I'm old. Anyways, you guys signed up for an internet class, so you didn't necessarily get inconvenienced by this, but I did have surgery over the break, so things are taking a little bit more time for me to get ready. I basically had surgery on Wednesday before Christmas, and it was sort of major surgery. They had to repair an artificial or prosthetic shoulder that they had installed about 8 years ago, and it suffered, and I quote, catastrophic failure. So because of that, I'm still recovering. I can't drive to campus right now. I'm also having some other difficulties just, getting stuff done. So anyways, my syllabus isn't up yet. I thought I'd have them all done by last night, but turned out I was having an allergic reaction, so I had to take a Benadryl, and I did not wake up till 10:30 this morning. So I will be working on this. I apologize. I did manage to get your MyLab and mastering course set up. So you can click in the left-hand side. For some reason, the weird link no longer says MyLab and mastering. It says Pearson at Cova-DE. I have no idea why that's the case, but it's working, so that's the main thing. It looks like Shanda's going on a walk somewhere, I guess.
I'm at my son's taekwondo because I had to come do that tonight for a reason, but my Bluetooth stopped working in there, so everybody was listening to me
Nice.
sitting. I had to come out to the car. Yeah, it just failed as you came on. Everybody was listening to
Well,
our
make
lecture.
sure you don't risk life and limb to listen to this by driving.
Yeah, it's okay.
Okay.
I can. It'll come through when I'm driving just for tonight. I just had a schedule. Usually okay.
No problem. If you feel any problems, make sure you just know it's going to be posted later, so you'll get it on the recording. So anyways, I guess we'll go ahead and get started. Anybody have any questions before we get started? We are using Giancolli's 5th edition of Physics for Scientists and Engineers. Some names I don't necessarily recognize here, so there's probably a student or two that hasn't had me before or didn't have 241 at TCC at all. If that's the case, I will tell you, if you had the equivalent of 241 somewhere else and you actually used the same textbook we had, depending on what license you bought, you might very well still have access to that MyLab and mastering. Otherwise, you're going to have to get access to it and that could involve you buying a lot, of stuff. In fact, it could involve you buying 2 sets of books and 2 sets of homework stuff for the 2-semester sequence. I hope that's not the case, but it might be. So, I will tell you that the cheapest route you can go, if you want to go the cheapest route, you can go to My Lab and Mastering. Specifically, go into our course, and you can go, for instance, to week 1 module, and you'll see homework chapter 17. You can click directly on that, and when you click on that, it should take you to the My Lab and Mastering page. They'll ask you for an access code or a pass key, something along those lines. If you bought a new book from our bookstore, then that means they gave you, quote unquote, gave you for free the access code so you could access the My Lab and Mastering homework. If you bought it from somewhere else, that might not be the case, but there are some booksellers that sell used copies of the binder ready book or used copies of the hardcover book or the paperback version, and they'll sell it to you with a shrink wrapped access code. So those are all options. But like I said, if you want the cheapest of the cheap, probably the cheapest way you can go is to just click on chapter 17 homework. And then when it asks for the access code, you're going to choose to purchase one. And when you purchase it there, you can purchase the ebook with a license long enough to finish this course. So this is a 242 course. You only have the rest of the semester left. So you shouldn't need any more than about 16 weeks. I think they sell 18-week segments or whatever, but that should be fine, unless you might be taking the course, the third part of this course, which a lot of universities offer and a lot of universities require and a lot of programs require, in which case you might want to shoot for a whole year because it's not that much more expensive. But the main thing is, if you buy it that way, you're going to get an ebook edition of the 5th edition of the textbook. And if you are okay with that, then you've definitely got away with the cheapest way possible. If you're not okay with that, if you still like a physical textbook, then the cheapest way for that is to buy the electronic book, like I suggested, the ebook. But then also you can purchase a 4th or even 3rd edition of Giancolli's Physics for Scientists and Engineers. Let me type this up here since the syllabus isn't up yet. But it's Physics for Scientists and Engineers, sort of a generic title that all these books basically use. And it says, with modern physics, 5th edition, Giancolli. So that's the textbook we're using. But like I said, if you just need a physical copy so you can read, you're not going to lose much by doing the 3rd or 4th edition will work as a physical copy, but you definitely have to have the 5th edition. Just in case, for instance, I give you a test and I say you got to do a certain problem out of chapter 5, out of the textbook. The problems aren't going to match, the problem numbers aren't going to match, a lot of stuff like that. So you still need access to that ebook edition of the 5th edition of the book. But other than that, you're good to go. So that's your 2 cheapest routes. Make sure you do that. They also give you a 2-week grace period, so there's no excuse for you to turn in your homework late. Your homework will be due. This class meets on Tuesday, so it will be due Monday at 11:59 p.m. So no matter what, that means if you don't have a book, that means if you don't have access to your homework set, I don't care. You're still going to get points taken off. You're allowed up to 7 days to turn in the homework late and get partial credit. But you are going to get that partial credit if you don't turn it in on time. So just make sure you go ahead and do that, because like I said, it's free. You can access it for a week or 2, or might even be 3 weeks. Can't remember, that they allow you for free. So even if you're not ready to have it right now, you can still access that stuff. Anybody have any questions about that? Okay, I'm going to type up my email address here. This video that I'm making will go up on my YouTube channel. And of course, if I spout out my email address, I'll get a ton of emails. I probably won't, to be honest with you, because I got like 12 people that look at my YouTube channel. But in principle, I could really get inundated with emails. Same thing with my phone number, which I'm also going to give you. Oh crap! I gave that to. No, I didn't give it. Okay.
I have a question. Is your YouTube channel, I don't remember, is it in the syllabus or did you just send us a notification so we
It's
could
in
find
the
these videos?
syllabus, and I'm getting ready to
Okay,
send that out too now.
that's right. That's right, it is. I just wanted to double check. Yeah, thanks.
I did leave an old syllabus up until I post the old one, until I post a new one. So you should be able to see at least the old syllabus, or even if you have my 241 syllabus, you can get all that from there. But I'm posting the URL right now for my YouTube channel.
I have a question.
Yes.
If we took 241 with you and we purchased the book, would we still have access to Pearson?
Yes, you should. If you've forgotten your password or something, you might have to call them to work that detail out. But other than that, yeah, you should just be able to log in with the same thing, with the same account, and now you'll have access to this course.
Oh, so I don't have to pay for new access.
You
Okay.
shouldn't have to. No. If I have had students that had such a runaround, they went ahead and paid for it a second time. I do not recommend doing that. If you have a problem, contact me, and I'll get in touch with my sales rep and see if she can't fix it for you personally.
All right,
Okay,
thank you.
yeah, on her question, I had it like, last semester with the Pearson lab, but when I went to look into the lab yesterday, it wasn't in there. I didn't have the physics class in there. I don't know if I went the wrong way. So you're saying it should still be good for a few more weeks for the rest of the semester? I thought I got the whole book for like the 2 semesters.
Yeah, it all depends. I mean, there is a license that they sell for a 1 semester course, and if you happen to have bought that version, which is moderately cheaper, then no, you wouldn't be eligible. But generally speaking, I made sure that our student store never ordered any of
Yeah,
those, or I asked them not to order any of those short sales.
I
Okay.
thought I thought I got the entire course, but because I knew I had to take it both, but I didn't see it. I'll have to check on that and get back
Yeah,
to you.
you might want to call Pearson about that, or whatever, or whoever. But let me know if you have any problems. I'll hook you up with my, or I'll at least contact my sales rep, and she usually works pretty hard to make sure my students are set up.
Okay.
Do
Thank
they
you.
have a technical support feature where you can talk to them about? I'm trying to log into my Pearson.
Mhm.
All I'm getting is a text screen that's not even close to the website. And every time I try to log in, I get the same text screen.
Okay, are you doing that from the internet, or are you doing that through Canvas?
I'm doing that through the internet, through Pearson
Okay.
Plus.
You should not ever in my classes. You should not ever try to access my lab and mastering through the internet. You should go straight through our Canvas. That being said, it shouldn't be doing that to you anyways. Okay, but
Yeah.
I do the My Lab through Canvas, but I do the Pearson, the actual textbook through.
Oh, gotcha. Yes, they have a separate Pearson app for the ebooks.
Yeah.
So yeah, that kind of sometimes is squirrely, but what I've noticed is whenever I have problems like that, I empty my cache and then it starts working. So you might want to give that a try.
Yeah, I'll try that. Thank you.
No problem. And yes, they do have technical support. You just have to call them, which is, early in the semester, it's a pain because you might have a long wait, but you shouldn't have to wait too terribly long. All right, so looks like I've got 13 of you in here. That's good. I just posted in my chat. I posted the name of the textbook with the edition and the textbook author. I also mentioned that the 3rd and 4th edition will work as physical copies. I sent you my email address. I want to remind you, when you send me an email, you need to follow the 3 rules. I'm typing them out now.
Okay.
Probably if you had me before, you already remember them. 1, only email me from your TCC email account. Now, I don't mean that I'm not going to accept it from another account. It just means that I probably won't see your message. If you're in a pickle and you can't access your TCC account and you need to get a message to me, I would recommend you text me at that point. But if you still can't text me, you could email me then from another account. It's just not very likely that I'll see it. So that's the first rule, is you must email me from your TCC email account. The second rule is you need to include your first and last name. And the third rule is you must start the subject line on the email with PHY. I'm just writing this out now. I'm not going to say it out loud. There it is. Okay, so y'all might just do a screen capture real quick so you'd have those notes and you don't have to actually write them down, or you can copy whatever you want to do. I'm just trying to let you know. I know some students have difficulties reaching the chats after they've scrolled up or whatever. So those are the 3 rules. Make sure you include that subject line as the first part of your subject. If it's the second part, I won't get it. So often what I do is I just go in and do a search for the first 7 of those letters to find your particular emails, and I'll just do a search for that in my email. And if that doesn't pull up anybody, then you're not going your email is not going to be read. Okay, so that's why I said make sure you do that. Not only that, if you don't give me your first and last name, that makes it problematic as well. Sometimes people will inadvertently think I have only one night class, and they'll say physics night class, and I actually have multiple physics night classes. So anyways, keep up with that. Now I'm going to type my phone number. Again, this is something I definitely don't want to put on the web. If I can remember my number. I just forgot it for a split second. So there's my personal cell phone number. And what I want you to do with that is if you send me an email and I don't get a reply to you within 1 business day, and this is what I mean by 1 business day. If you email me Friday, Saturdays, and Sundays are the weird cases. Okay. But if you email me as early as 12:01 a.m. Friday, meaning it just became Friday from Thursday. It's 1 minute after midnight. If you email me that early on Friday or that early on Saturday or that early on Sunday, then I have to reply to you by 11:59 p.m. on Monday. Okay. All the other days is just the next calendar day. So if you do that on a Monday, I have to reply to you Tuesday. If you do that on Tuesday, I have to reply to you on Wednesday. But if you're doing it on Friday, Saturday, and Sunday, I have until Monday to reply to you. So if you send me an email properly formatted, like I just put in those 3 rules, and you don't get a response from me within 1 day, as I just explained, then that's a perfect time for you to send me a text message. Make sure you include, of course, your first and last name and your class with the section number, just like you do in the email. That way I'll know who I'm talking to and know what class I'm talking about. So that's a good reason to send me a text message. If I determine from our discussion via text that we need to communicate a little more easily, then I can either call you or I can set it up so that you call me, or I can set up a Zoom meeting or whatever. Just don't call me initially, because I'm just never going to answer a phone number I don't recognize. Y'all probably are experiencing the same thing with all the spam you get nowadays on cell phones. Another instance where you might want to use my cell phone to call me, or excuse me, to text me, is if it's something that's really time critical, like you're driving in for a face-to-face midterm exam or something like that, and you get stuck in a traffic jam. That's a good time for you to send me a text and say, hey, Mr. Younger, I'm sorry, this is first name, last name in class, blah, blah, blah. I'm going to be late for class, or I might not even make it, or something like that. That's a good time for you to go ahead and text me. But that's really the 2 times you need to text me, is when I haven't replied to you and you need a reply, but I haven't replied to you within the 1 business day, like I said, or if it's something urgent. Okay. So hopefully everybody has that. All this stuff will be on my syllabus. It's just I needed to give it to you now because my syllabus isn't up yet, and I apologize for that. Hopefully I will get it done tomorrow, tonight, maybe tomorrow afternoon or something, but it should be up pretty soon, unless I'm still having some allergic reaction. But if I have to take another Benadryl, I might not get anything else done tonight. So anyways, everybody clear on that?
Yes. Yeah.
Speaking of Shanda, since you just spoke, Shanda, I will let you know I have a couple students that have asked if they can attend a different lab. Like I actually have some day people that would like to attend my night lab, which is not me. It's Ms. Raskovic is teaching it. And I have some night people that want to attend my day lab. which is a lab that I teach. So I can work with you on that. You just need to let me know, and it's got to be approved by Ms. Raskovic or whoever the other instructor would be. We don't have to do it officially on the books either. We can do it off the books because sometimes that's just easier. It's just a matter of I need to make sure you guys know that. We don't want a lot of that, but if we get about equal amounts, it's not too big of a deal because we do have some classes that are maxed out full, and our labs are the only thing that really inhibit us from adding more students. Our labs are really made to hold 24 students. We can hold, one or two more fairly easily, and we're not coming near a dangerous situation. It's just a matter of it's not very convenient for a lab. So just let me know if you need something like that. I've already talked to Shanda with regards to her, and I've talked to a couple other people, but let me know if you still have that problem. I think Logan was another one. Anybody else have any questions or anything?
Yeah, is that the extra credit that you already posted? Was that from last semester, or is that something that we're doing for this semester?
It is from last
1 divided by
semester, but I
240
posted it again so you can still
for
get the
this one.
credit. Yeah.
So the octaves, the fifths of the rule of the fives, so the 1 to 243 and the windshield one.
Yeah.
Those are both okay. That
Yep.
one. And what time do you post these recorded classes?
I try to post them the same night, like tonight
same
after
night,
this
okay.
one should be posted, but sometimes the internet's too slow and I can't post it till the next day, but I rarely
Okay.
wait further than the next day.
Yeah, it's fine.
Okay. And they will be on my YouTube channel. That being said, that means, hey, you guys, like right now I'm looking at all your names and everybody's got your full name, which I prefer, to be honest with you. And some of you are showing me your faces, which I also prefer. But if you have some situation, and it could be a real situation that, maybe you're, on the run from the man or something. If that's the problem, then by all means, let me know and I'll do what I can to make sure you don't appear. But in the meantime, what you can do is change your username to just maybe your first name and then your first initial of your last name, and maybe not show your face. This is the first time it's ever happened, but yesterday I was teaching a class, and when I finished recording it, it showed the photos of the people off to the right of my window, which I'd never had that happen before. I did not change anything in my Zoom settings, but it's not something I wanted. But be advised that does happen. And if you have something, whether it's real, imagined, or you're just worried about it, it's still your right to say, I don't want my face or name on the internet like that. You let me know and I'll do what I can to make sure that doesn't happen. Okay. So make sure you send me an email about that. And if the sooner you send it, the better, because like I said, I'll be posting this tonight, hopefully. And editing is not a trivial thing. But anyways, we'll see what we can do. Okay. All right. We're going to start this semester. First, I want to ask, and y'all can reply via chat. That would be fine. Or you can just speak right up, whichever one you want to do. I'm assuming that, like my class, anyone that's had the equivalent of 241 last semester or anytime in the past did not cover thermodynamics. Is that not true for any of you? Have any of you already covered thermodynamics in the previous course, calculus based? Okay, it doesn't look like anybody has. That's good. So what that means, good, thank you, ML. So what that means is I will be starting with the first chapter that counts, will be chapter 17 of our textbook, which is on temperature, the atomic theory of matter, and stuff like that. So that's what we're going to start covering. First off, you'll see, I think I posted chapter 16 as an extra credit, and that's okay. It is another homework assignment that you're welcome to do as extra credit. If it's not up there though, don't worry about it, because it just came with the class from where I'd offered it before. But like I said, I don't care too much about you doing it, but it's nice because that's a chapter that we usually don't get to cover, and you could actually cover it. I want to say it was fluid dynamics or something like that. But anyways, y'all can do that. Any of them that have the EM after it, or any of them that are not chapters that I told you we're going to cover, they're automatically going to be extra credit. I said EM, EC is what it'll have on it. What I plan on covering this semester is what I'm getting ready to type out here on the following. So the chapters I plan on covering is 17 through 31. And then maybe quantum mechanics. I'll give you more details on that quantum mechanics stuff later, but I'm pretty confident it's 37, 38, and 39 are the chapters for that. Sometimes I do quantum mechanics, but only cover 37. Sometimes I only cover 37 and 38. And sometimes I cover 37, 38, 39. Sometimes I even go far enough to get into nuclear physics, which I think is like 40. But here's the chapters that we're supposed to cover. So by default, any chapters that are not in those numbers are automatically going to be considered extra credit, even if they don't have the EC on it. So all others are definitely extra credit. I'm typing this up for you here. I don't normally do this much typing in here, but I'm doing it right now just to make sure y'all see it in writing once, since I don't have the syllabus up in front of me. All right, so I think I've introduced enough stuff about the class, other than I'll tell you that basically the way this class is going to run is, since you're a Tuesday, Thursday class, every Tuesday, sometime during that day, hopefully first thing in the morning it's already done. But I rarely ever wait later than 5 p.m. But by 5 p.m., usually on every Tuesday, a module will pop up in Canvas and it'll say week. For instance, this week is week 1, or next week it'll say week 2. It'll say week 1 or week 2 or whatever, and it'll have the string of dates that week covers. So, for instance, when we're off for spring break, in some sense, you're doing it on 1 week, but you literally have 2 weeks to cover. So sometimes that'll show up, but that will happen every Tuesday. And then all your homework for that week, unless specified otherwise, will be due at 11:59 on the following Monday. So just keep that in mind. That's just something that's going to happen every time. And it normally involves at least 2 homework sets. One is called chapter HW, meaning homework problems, and the other one's called, chapter conceptual, which is conceptual homework, and therefore not problem solving. But occasionally I have 2 or maybe even 3 homework sets for a given chapter. So just be advised that's always the case, and unless it explicitly says otherwise, anything assigned in a given week is due that following Monday at 11:59 p.m. Okay. I do allow, like I said, you lose some points each day, but I do allow you to turn it in up to 7 days late, but you are going to lose some points. Now, one more time, anybody have any questions on any of that stuff? And by the way, if you miss any of this chat stuff, I think there's a way I can download that file and send you whatever you might have missed. So if you send me an email saying, hey, I missed that, let me know. It says, have you posted any work yet for the Canvas course? Yes. Yes, the course. Oh, actually, okay. So I just saw that this was another student. Logan, I am working on that. For the first time, this wasn't done last time. For instance, for the first time, they created a shell course in Canvas for the college that you're working at, and I'm not interested in creating twice the work for myself. So I'm currently trying to get them to put you in my course here at TCC. Otherwise, I'm going to have to literally do double the work for this course. So there's nothing in your course right now. And I don't know what to tell you beyond that, but if it doesn't get fixed by first thing tomorrow, then I'm going to have to give you extensions on homeworks and stuff of that sort, because this is none of this is about you. This is all about our schools and me. So I'll take care of that. Sorry about that, Logan. Yeah, I just discovered that literally today. I just discovered some other stuff today. For instance, your grade was never turned in last semester, specifically because I had no access to SIS. And today I found a way, and I submitted your grade from last semester and all that good stuff. But I'm waiting for a word back on them. So I'm glad to have you back though, Logan. All right, so let's get started. Anybody else before we get rolling? Okay, so like I said, if you look off on the left-hand side of our Canvas page, you'll see that on the left-hand side, it goes home and then there's syllabus. I never put my syllabus there specifically because that makes really cool looking stuff for some people, but every time I've done it, it looks like crap. So I just put it in a separate module that'll say important course documents, and that's where my syllabus will be. Then there's a lockdown browser link. That's where you're going to go to make sure your lockdown browser, your Respondus lockdown browser and Respondus monitor stuff is all up to date. Because if I do decide to take what I call a face-to-face proctored exam, but allow you to take it from home, you're going to have to be required to have a lockdown browser with Respondus monitor and a webcam and all that stuff. So that's where that goes. That's where that comes from. Then there's a link for Zoom, where it has all our Zoom meetings and passwords and all that stuff. Then there's the link Pearson at Nova-DE. Again, don't know why that's called Pearson at Nova-DE, but it does work. I've clicked on it and it takes you to the actual MyLab and mastering. So the rest of the stuff is as usual. The modules is where you find the week 1 module, week 2 module, and the interesting science links and all that good stuff. There's a grades link over there, and so on and so forth. So what I'm going to do now is jump into chapter 17, which is called Temperature, Thermal Expansion, and the Ideal Gas Law. So a large part of this I can do without really any notes, because I need to introduce you to the atomic theory. Okay. And the atomic theory is basically sort of like a joke I just heard on Big Bang Theory. I've heard it in other places too, but I was rewatching season 1, or might have been a later season of Big Bang Theory the other night, and Will Wheaton made a joke. He said, why can't you trust atoms? And it said, because they make up everything. And that's sort of right. Okay. They really do. They make up all the normal things that we call. They do not make up, the things that we don't normally discuss, unless you're nerds like me. So they don't make up protons. They don't make up neutrons. They don't make up electrons. And then they don't make up quarks, and they don't make up, mu meson, or excuse me, it's not a mu meson anymore, but they don't make up muons anymore or any of that kind of stuff. But that being said, they do make up all of nature. And once you have that little idea, you can do a surprisingly large amount. For instance, one time someone asked Richard Feynman if you could pass on just one sentence to future generations, maybe in some post-apocalyptic world where we've had some kind of nuclear war and everybody on the planet is going to die except for a very few number of people. And those people might even be children right now. What sentence would you send off to them to help them progress and get back to a state of health and happiness? And he said basically that he would give them the atomic hypothesis, that the universe is made of these small, nearly infinitesimal particles that vibrate, and that vibration is directly related to the temperature of the object. So that kind of idea might not seem that compelling, but what I'm going to do now is try to convince you that it is fairly compelling. So if we go on the assumption that what Democritus decided was right. So Democritus was an ancient Greek citizen, and he basically did a little thought experiment, not unlike what Einstein does, where he said, let's imagine, oops, somebody got bumped out hard. Hold on here. He said, let's imagine we take something. Now, in ancient Greece, they didn't know about elements and compounds and all that fancy stuff. So they might just pick up a rock. I would ideally like to simplify that a little bit, even though that's inconsistent with what Democritus said. But let's imagine that he picked up a rock that was small enough to be completely made of either iron or copper or aluminum or titanium. Some pure element is the key point here. As a modern person, we understand what that means. What he said was just a thing. So Democritus said, if you just pick up an object, there's two possible outcomes. You can take that object and you can cut it in half, and then you can throw away one half, grab the other half, cut that in half, and then you can take another half, throw it away, take the remaining half, cut that in half, and keep doing that over and over and over again. And there's two outcomes. Either you can do that forever, which he thought was philosophically untenable, and therefore threw that away, or you're going to get to some smallest part that cannot be divided further. And in ancient Greece, the word tom was basically the equivalent of divisible, and prefix of meant not or non. So he concluded that that was the case, and he called that smallest indivisible part an atom, an atom. Okay, that was his idea. And as evidence of this, he suggested, for instance, when you're walking down the street and you smell bread baking, that is basically these atoms of bread floating around, wafting in the air, and then entering your nostril. And entering your nostril, you then smell it. And believe it or not, that's actually fairly accurate. He didn't necessarily understand the difference between atoms and molecules and that sort of thing. And molecules are generally what we smell that are characteristics of certain smells. But the way it sits on the air and disperses outward, that's all pretty solid science. So it does. And in fact, that you can take from that what you will. If I can make a joke, yeah, those horrible smells that you get when you're hanging around with your dog or maybe your toddler, and it enters your nose, that is literally a molecule that just came out of something's rectum. So yeah, awesome. I generally like to breathe through my mouth in such instances, but I heard it on Letterman one night. Cindy Crawford was being interviewed, and she said something along the same lines. And then she said, "Well, but my mom pointed out, would you rather eat a fart or would you rather smell a fart?" So I thought that was pretty good. Good reasoning by both Cindy Crawford and her mother. So anyways, yeah, that's something to think about, but that is actually the mechanism, and hopefully that entertains you a little bit. I will remind you, those that didn't have me those that did have me before, I'll remind you, and those that haven't had me before, I'm telling you from the start, I'm chronically stuck in, somewhere between 4th and 6th grade. I'm still that little kid, so I still, get a kick out of making jokes about poop and pee and butt and stuff like that. So if I offend you, I apologize. Let me know, and I'll do my best not to. But I find that it normally keeps students somewhat entertained. All right, so that was the idea that Democritus had. We've since discovered that, yeah, if you actually do take a pure substance, which is the things that are listed in the periodic table, so hydrogen, helium, lithium, beryllium, carbon, so on and so forth, those things are pure substances. And yes, if you took a chunk of those and you cut it in half, cut it in half, cut it in half, cut it in half, and keep cutting it in half, you'd eventually get to a smallest part that wasn't not divisible. You can actually still divide it. We've since learned that with enough energy, you can certainly divide a atom or break open an atom. But the main thing is it would no longer act like that element. So for instance, if you took a carbon atom, you could, in some sense, figure out the properties of carbon based on just that atom, and the atom would behave accordingly. But if you broke that atom apart, it wouldn't continue to behave like carbon. Okay. Similarly, if you don't have a pure element, if you have, for instance, a compound, compounds do sort of the same thing, only they're made up of multiple atoms. So for instance, there's molecular oxygen, there's molecular hydrogen, there's molecular nitrogen. Those three things bond with themselves. So there's H2, N2, and O2. All three of those come as a molecule in everyday life on Earth. In space, it's not so much that, but on Earth, it's like that. So those are molecular. And they have the oddity that if you did reach that smallest part, you break it apart and both parts would still behave the same way. And then if you tried to break those two apart, then it'd be different. Outside of that, there's non-diatomic molecules, compounds that are made of more than one type of atom. So for instance, H2O, which has 2 hydrogens and 1 oxygen, that's clearly not a diatomic molecule. That's a molecule made of 2 different types of atoms. And if you took a chunk of water, obviously it has to be frozen, and you cut it in half, and then you take one of those halves and you cut it in half, you take one of those halves, cut it in half, and keep on doing that, you'll eventually get down to the smallest part of a compound, which is a molecule. Now, again, we don't believe that molecules are indivisible. We know for a fact that we can break them apart, and we can even do it with just chemistry. We don't need physics. We don't need nuclear physics to break them apart. But when we broke them apart, if I broke apart, for instance, a water molecule, the resulting parts would act nothing like water. I would have something acting like hydrogen, and I have something acting like oxygen. Okay. So that's the current idea extended from Democritus. And if you went further, there are things other than compounds and elements, and we just call those mixtures. So, for instance, a tossed salad is a mixture. If you go cutting it in half and doing that kind of stuff, you're going to get all sorts of weird stuff. For instance, lettuce or tomatoes, you're probably going to get to the smallest part being a cell, but you can still break a cell apart, and then you're going to get the little parts of a cell, the cytoplasm, and all that good stuff. But then those actually reduce down to atoms or compounds or elements or compounds as well. Okay. So we don't have to really bother ourselves with thinking of mixtures, but I just want to let you know that is the other category. So now what we have is an idea that elements have as their smallest part an atom, and compounds have as their smallest part a molecule. And it's not that they're indivisible, but rather that they don't have the same properties if you divide them. So if you break up their smallest part, it's no longer acting like that substance it was. And now we go with the next part, which was the jiggling. So what we have found, at least since quantum mechanics, is it turns out you can't make atoms come to a stop. There's a principle called Heisenberg's uncertainty principle, which is an easy back of the envelope, fuzzy science way of just saying you cannot tell both instantaneously with any high degree of precision, both the position and velocity of a microscopic thing. Okay. That's Heisenberg's uncertainty principle. So if you were to tie down an atom or just at least make an atom stop moving, the fact that it's not moving tells you, the velocity is zero. And that's pretty much understood to be zero with zero uncertainty. And that means you're going to have no idea where the heck it is. And if you try to nail down where it is, you're going to have no idea how fast it's moving. And that's just a fundamental law of nature that we haven't been able to find a way around. No ifs, ands, or buts about it. And it's not just with position and momentum. There's other conjugate variables that do the same thing, energy and time, for instance, some of which actually saves us. It allows for the creation of virtual particles and stuff like that. But so what we do know is the atoms or molecules are constantly in motion. And what we also know is it turns out those atoms and molecules are in motion, and the kinetic energy of those atoms or molecules is directly proportional to the temperature in a very specific temperature scale. Okay. So the very specific temperature scale is either the absolute, or both of them are absolute scales. One of them is called Rankine, and the other one's called Kelvin. We're not going to do much with Rankine, but we will do quite a bit with Kelvin. So I just wanted to let you know there are two absolute temperature scales, one of which is Kelvin, the other one is Rankine. And you'll notice I say Kelvin, not degrees Kelvin, and I say Rankine, not degrees Rankine. That's because they are absolute temperature scales that are based on something fundamental, not something arbitrary. Hence, we don't use a degree. For instance, you might have noticed and been curious about this if I hadn't already told you, or someone else hadn't already told you. Why do we use degrees to talk about an angle in a triangle? And we also use degrees to talk about temperature. And we also use degrees to talk about longitude and latitude. Why does degrees pop up in so many different things? Well, that's what I'm pointing at, is the degree indicates a measure of arbitrariness. So the ancient Sumerians had a base 60 number system, and the number 360 was really a good number for them. And it's really a huge and good number for us too. And what I mean by that is 360 has a lot of factors that go into it. So for instance, 360, you can already see it's even, so it takes 2. You also know that it's a multiple of 3. You also know that it's a multiple of 4. You also know that it's a multiple of 5. You also know that it's a multiple of 6, and so on and so forth. That's what makes 360 such a nice number. And that's what they decided to make the total number of degrees in a circle to be, but that's completely arbitrary. There's no other reason. In fact, you could come up with another number, maybe 720 would be even better. Because it can fit even more factors than 360 could. So it is somewhat arbitrary. You might argue that the temperature of Celsius and Fahrenheit are not that arbitrary because they're based on, hopefully, you know, water. The 0 of Celsius is the freezing point of water. The 100 of Celsius is the boiling point. The 32 of Fahrenheit is the freezing of water, and the 212 of Fahrenheit is the boiling of water. We as humans recognize that water is extremely important to all the living species we find here on Earth, or essentially all of them. But in principle, we could ultimately sometime long in the future discover another species, probably from another planet, not in our solar system, but another planet somewhere else, or maybe even in another galaxy. That would be a really long time from now before we run into such a species. That species might not need water, might not need water that much anyways, in which case, yeah, the based on water is kind of arbitrary. So that's what we're looking at. That's what the temperature systems are, and that's why the arbitrariness. So we've already reached the conclusion that temperature is directly related to the kinetic energy of the atoms or molecules that make up the substance. So if you think about something somewhere near 0 Kelvin, where molecular activity is as close to not moving as possible, then you see the little atoms or molecules and they're vibrating like this and everything's good. Well, at a particular vibrational amplitude, there becomes an equilibrium distance between adjacent atoms or adjacent molecules, because there's forces of attraction between this atom and this atom, or between this molecule and this molecule, and they reach equilibrium at a very set distance apart, and that distance is generally how far apart they are when they're in the solid state, like in a lattice or something like that. So what you see, though, is if the kinetic energy is directly proportional to the temperature, so if I then increase the temperature of the substance, then the atom and molecule are going to start to vibrate more quickly, and that's going to cause the equilibrium position to be further and further apart. That suggests to us that in general, matter should expand upon being heated up. In other words, when the temperature of a object increases, we expect its size to get bigger. We can't tell you much about how much bigger, but we know it should get bigger just because of the idea of the atomic theory. Okay. If you continue on, though, you could, in principle, continue going to such a high temperature that they vibrate so fast that the small force holding them together at some equilibrium distance isn't strong enough to hold them together anymore. If that's the case, then they break out of that lattice, which is sort of like a big piece of graph paper. And you imagine anywhere two lines come together, that's going to be a location of a molecule or an atom. And then in front of that's another sheet of graph paper with atoms at each of those crosses, or molecules at each of those crosses as well. And by doing that, you can see, in some sense, a three-dimensional lattice of atoms or molecules. And that is what makes up a solid. It normally has some kind of lattice structure, some smallest part of which is representative of the whole. And that's what happens for a solid state. But if you reach a temperature that's so high that that force that was holding them in that lattice is insufficient to hold them, then they're going to break loose from that lattice. And then the atoms or molecules can actually sort of roll around as if they're rolling on top of each other. They're vibrating still, but now it's like the distance between them is bigger. So it's almost like the atom's gotten bigger itself. Because they're vibrating against each other. And this atom right here might spend a good fraction of time, maybe on the order of whole seconds, around that one particular atom, but then it's going to go off and get caught up on another atom and stick near there. That is actually the way liquids behave. They are it's sort of like they're rolling on top of each other, because the nature of a solid is that it has a very specific volume, it has a very specific shape. But that's not the case with a liquid. When you do a liquid, it has a very specific volume, but not a very specific shape. It takes the shape of the container. Okay. So at the liquid state, these things can roll all around, so they can transform to any shape you want. And if you continue to heat it up, they're going to get more loosely tethered to those atoms that they're sort of sticking around, even though they're only sticking around a particular atom for a very small period of time. It's still more time than they will do later at higher temperatures. And they're going to start to roll around other ones. And eventually they'll get to moving so fast that even that little force that tends to make it stay closer to its nearest neighbor, that force isn't enough to hold it together. And then they're going to be more or less completely apart, at which time they become what we call a gas. And a gas doesn't have a definite volume nor a definite shape. To some limits, there is no amount of volume that a gas can fill. So I can't fill. So if you took this room, for instance, I'm in, and you sealed it off perfectly, you could put a small amount of gas in here and then come back a couple hours later, and every part of the room would have some gas in it. It might be at extremely low pressure, but it would be in there. Now there are limits to that. Obviously, if I took a collection of gas that was maybe 1 mole of atoms, that's a butt ton of atoms, but it's still very small compared to everyday life. If I just contained a mole of atoms, this room would certainly easily be filled by a mole of atoms of a gas. But if you made a room, say, the size of the Mall of America, that might be a little too big to stretch the atoms out so far. So there is some limit to how big a volume a certain number of atoms can cover, even as a gas state. But that's an area of physics we don't study too much, and it's non-equilibrium and all sorts of stuff. But let's look back. We just used the atomic theory of matter, and we reached the conclusion that as temperature goes up, materials expand. As temperature goes down, materials contract. That's a physical phenomena that's helpful to us. And in fact, we can make up equations for it, and we're going to give you equations for it in this chapter. And then we can also say that, yeah, they're also, if you heat it up enough, it's going to go from a liquid state, from a solid state to a liquid state. And if you keep heating it up further, it's going to go from a liquid state to a gaseous state. And if you keep heating it up further, it's going to expand and expand and expand more. So that's all neat stuff, but we all figured it out from the atomic theory of matter. There's a lot of other things we can figure out as well, but that's some of the key stuff. Anybody have any questions on that? All right, so let me share my screen with you. We don't have too terribly much time left. We got 27 minutes left. So I'm going to share my screen with you, hoping everything works properly. So far, so good. Still not connecting. Hold on. Should have connected by now. I don't know why I didn't. Is it trying still? Looks like it's still trying. Up there it is. Finally. Okay. Just took a little delay. Maybe it's old and forgot some of the stuff it's supposed to do since last semester. Anyways, we've got it done now. I'm going to make sure I turn on the chats because I know some of my students don't necessarily speak up. They're trying to be polite. So I won't see it unless I actually have the chat open. So let me whoa, I don't know what I did just then. Okay, so I just lost literally everything on my screen and I don't know why. Okay, there it is. I must have did something funky with my mouse pad because it just all of a sudden started acting really weird. All right, so the atomic theory of matter, as I said, gives us an idea about atoms. And of course, we've now rendered that to be consistent with not only atoms, but the modern interpretation of atoms and the modern interpretation of matter, which includes compounds and elements as well as mixtures. So I'm going to start off with getting you to think about the periodic table. So for instance, if you look at the periodic table, you'll see, for instance, that the atomic number, which is the number Z of carbon, is 6. And what that means is that the number of protons is equal to 6. Now, you might not necessarily look at it this way if, for instance, when you learn this kind of information for the first time, you normally don't understand that much about quantum mechanics and other things. So you might say that it's the number of electrons you have. And that's generally true. It's true for a neutral atom. But I want you to understand that if the number of electrons is 6, 7, 8, 9, 4, 5, 2, or 0 even, uh, if the atomic number is still 7, is 6 for the element, then the element and the atom is still carbon. Okay. So carbon is carbon is carbon, no matter how many electrons it has. It just happened to be this nice case where the number of protons is usually equal to the number of electrons because most matter is neutral. Okay, so that's something to keep in mind and something you really want to think about. It really is the number of protons that matters. Ultimately, when Bohr came up with his Bohr model of the atom, which was one of the founding things for quantum mechanics, what we discovered was really the number of protons and the neutron was all that mattered in making up the orbitals for the individual atom of hydrogen. So that continued to go on. And in fact, it really is just the number of protons that dictates the orbital configuration. There are some other things that affect it, but not nearly as much as the energy from one orbit to the next. That doesn't change by an appreciable amount by those other things. Okay. You can, for instance, take the certain gases that you'd find in a red giant, which is our red supergiant, which is a really supermassive star that's huge in size. And because it's so loosely packed and such a usually fairly low temperature, there's very few collisions happening that often, and that tends to make the lines from the spectra very, very crisp. Whereas if you took a regular star, you would find that the lines are quite blurry. That's because collisions and things like that have affected the orbital energy such that some of them are a little lower than normal and some of them are a little higher than normal. And therefore the spectra, which indicates something about the orbital level, is often blurry. Okay, so there are other things that actually affect the orbital structure of atoms, but generally speaking, the main player is the number of protons, period. Okay. So atomic number gives you that. We also know that the atomic mass of carbon is 12.011. Now I didn't put a unit on here on purpose. Does anybody recall or know what that unit should be? When I look on the periodic table and look up the atomic mass and it says carbon's atomic mass is 12.011. Does anybody know what the unit is? Looks like somebody wrote in the chat. Ah, very good, Reynolds. That's not what I was shooting for, but that is what you're supposed to be learning today. He said it's actually a unified atomic mass unit, and he's absolutely right. That is one of the versions, but I was not going to give you that up front because most people don't know it. Does anybody know another version of what it is? The one that you might have learned in chemistry, for instance? It does not appear that anybody remembers or is interested enough to let us know. I'll tell you that in general, what I always read it as was grams per mole. And by thinking of it that way, even though I don't think my instructors necessarily harped on the point very much, but in me thinking about that, I was able to solve a lot more problems than I really would normally be able to solve. So that really is supposed to be the fundamental sort of idea of what the mass unit is for the atomic mass on a periodic table. But it's a little bit more complicated than that. In fact, what that atomic mass unit, atomic mass is this. What we do is we take the atomic mass, and that's actually equal to a weighted average. So it's the percent of, let's say, carbon. Let's go all the way down to, and this doesn't necessarily exist, but let's say carbon. I don't want that one. Yeah, I do want that one. carbon-6 times the mass of carbon-6 plus the percent of carbon-7 times the mass of carbon-7. And I'm just trying to be thorough here. I know for a fact that these isotopes of carbon probably don't exist at all. And even if they did, the percentages would be so close to zero that we probably haven't even made a measurement of it yet. But the point is, I'm going to keep on until I get to, let's say, percent carbon-12, which is the most abundant one, times the mass of carbon-12 plus percent of carbon-13 times the mass of carbon-13 plus the percent of 14 carbon times the mass of 14 carbon plus ... So that's what the actual mass is in the periodic table. In other words, we take all the isotopes of the atom that exists and we determine in nature what percentage of all the atoms of carbon that you find, what percentage of them is carbon-6, what percentage of them is carbon-7, what percentage of them is carbon-8, carbon-9, carbon-10, 11, 12, 13, 14, 15, 16, 17, however many it goes up to. And by doing that, we just multiply the percent times the mass plus multiply the next percent times the next mass and add all that up. And basically then you get the 12.011 grams per mole. And they actually probably have it to a couple more sig figs than this, but that's basically what I'm given on Granger, their periodic table, which by the way, Granger has a really nice periodic table. I don't know if you're familiar with Granger, but that's a industrial company that sells all sorts of cool stuff for industry, electricity stuff, building stuff, HVAC stuff, all that kind of stuff. But I found a really good website with their periodic table on it. So hopefully you all knew that. Did anybody not know that? It's fine. It's not, I mean, not knowing something has nothing to do with your intelligence. It has stuff to do with what you've been exposed to. So that's why when my professor, I admitted to him that he had written a book on the atomic bomb, and I found out he wrote it, and I saw it in the library, and I saw it in the bookstore, and I started talking to him about it, and I said, heck, I'll have to read that sometime. I don't even know the difference between an atomic bomb and a hydrogen bomb. And he said, well, that's because you're ignorant. And I looked at him, and I was like, yeah, that's right. Okay. But that's the way a lot of, he's sort of a Sheldon-esque type character from Big Bang. But that's the normal thing. And hopefully maybe that'll take, you'll be able to take that with you and maybe boil down or at least bring the heat down on an argument on Facebook. Someone calls you ignorant, that's not necessarily an insult. If they tell you you're ignorant about your job, something that you're supposed to be good at, then yeah, that's kind of an insult. But anyways, all right, so we've got this now. We've got the atomic number is the number of protons. We have the atomic mass, which is also sometimes called the atomic mass number, but that's a different scenario. That's when you're actually counting the total number of nucleons. When you have that, that's the actual number that I'm seeing here as a left superscript. That guy right there. So like 12 carbon. That's the number of nucleons. In other words, it equals the number of protons plus the number of neutrons. Okay. So just keep that in mind. That'll come in more handy if we ever get to the chapter on nuclear physics. But right now, that's enough for us to know right now. Now, here's the neat thing. What we wanted to do was come up with a unit for mass that was a lot smaller than a gram, right? We already know the metric system goes all the way, to several powers of 10 in the negative range. For instance, femto is 10 to the negative 15th grams. A femtogram would be 10 to the negative 15th grams, that kind of thing. That's pretty small, but it's still not very small compared to an atom or a proton or something like that. So they went for something more, and that brings us to what Reynolds said. Specifically, what was done was it was decided that the unified atomic mass unit given the symbol U. I think I might write that somewhere else instead of writing it there. Looks like I don't have enough room. Oh, maybe I do. Let's see. Would be defined such that, by the way, I love this. That's a neat little symbol that a lot of people use for such that, by the way. It looks like a cursive S and T if you're familiar with cursive writing, but it's must be defined such that carbon 12 has a mass of exactly 12.000 U. Now, I often will just put a bar over those 3 zeros to say it's supposed to be 12 with an infinite number of zeros. That being said, I've never seen the original documentation, so I'm not sure. I'm pretty confident they are counting that as the entire mass of the carbon-12 atom, which includes the electrons. Okay, and electrons are about 1,000 times lighter than the protons and neutrons. If that's the case, then once you start to get about to the third decimal place, stuff gets a little hairy, even for carbon-12. So that's what I'm trying to express here. But that's what they decided. And if you look at that, they're like, okay, well, wait a second. Carbon-12 has a mass of 12 atomic mass units, but it also has 12 nuclear particles, or 12 nucleons. The nucleons, like I said, proton and neutron are pretty close to the same mass, not exactly, but they're pretty close. You haven't learned this yet, but relativity and chemistry and physics in general teaches us that, in fact, the mass of 6 protons and 6 croton. I think I just said the mass of 6 protons and 6 croutons. I don't know where that came from. Anyways, what I was saying is you should know that the mass of 6 protons added to the mass of 6 neutrons is an entirely different number than the mass of a nucleus that has 6 protons and 6 neutrons in it. In other words, once you bond them together, they actually get lighter because it takes it actually takes some energy, which can be related to mass by E equals mc squared. It takes some energy to hold them together, so that the mass can be quite different. So because of that, there's a little bit of weirdness, but let's think about it for a second. We're roughly saying, by calling this 12U, we're roughly saying that each proton and neutron should have roughly a mass of about 12, or excuse me, of about 1U. That being said, ooh, since carbon-12 has 12 nucleons, one U is approximately equal to the mass of one nucleon. Does that make sense to everyone? I should probably write that on the next line. Let's see. Since carbon-12 has 12 nucleons, dang it, stop it. It keeps doing that. We may conclude that each nucleon has a mass of 1 atomic mass unit. Now, how many mass units, or how many nucleons does hydrogen have? Just regular hydrogen, not hydrogen 2 or hydrogen 3. Oh, I just wrote an H in place of an S. Does anybody know that answer? Anybody know how many nucleons hydrogen 1 has? I'm actually asking because it's going to help you see something so you don't have to think about memorizing the conversion for this thing. Yes. Is that MI or ML? I think it's ML. Yes, milliliter. Milliliter says it's just 1. That's right. And it's called a proton. Very good. Excellent. Yeah. And don't feel bad about forgetting this stuff. I forget all sorts of stuff. So 1 is the answer. Does anybody remember off the top of your head what the molecular mass of hydrogen is? Or what the atomic mass of hydrogen is?
Is it 1.01?
There you go. Mass of, someone said 1. I think they said 1.01 or something like that. In fact, that's right. I'm looking at the table and it says 1.008. And with the periodic table, like I said, one way we can think is grams per mole. So if that's the case, then hydrogen, ignoring the idea of taking the weighted averages due to all the isotopes and all that good stuff, we sort of could say that's roughly 1 gram. Obviously, we'd have to go out to the hundreds place to get it to round up, or even the thousandths place before we get a non-zero digit. So I'll ask you this: according to this atomic mass, how many atoms? How many hydrogen atoms are in 1.0 grams of hydrogen? I'll give you a hint. There's a word that helps you a lot. It starts with the letter M. So how many hydrogen atoms are in 1.0 grams? And again, I'm only trying to pretend like the number's only expressed to 1 decimal place, so you can ignore any other decimal places. Exactly. ML said 1 mole. And 1 mole implies the number is Avogadro's number, right? So if I take this 1.0 grams of hydrogen atoms has Na atoms in it. It's really getting bad. My handwriting down at the bottom of this thing. Ah, dang it. Okay, so I told you that 1.0 grams of hydrogen atoms has Avogadro's number of hydrogen atoms in it. So what is the mass of a single hydrogen atom given those two numbers? And you don't actually have to use the number, you can just use the symbol if you want, but anybody can answer that? It's gonna be like a eureka moment, hopefully. ML or Reynolds, y'all know that? Anybody else willing to speak up? So let's say a car weighs 1,000 pounds. what would 6 cars weigh? There you go. Reynolds said it. Yes, the answer I was looking for and was trying to motivate with the car story is basically 1.0 grams over Avogadro's number equals basically, I'll do 1 divided by 6.022. There's actually a longer version of Avogadro's number that I'd prefer to use here. I'd like to have at least 2 extra sig figs. Let me do a Google search for that real quick while you're waiting. There you go. Not that one. 2214, 6.02214 times e to the 23rd. That gives me 1.660. 5. Notice I did a space after the first 3. And that's grams per atom. Okay. Now, according to what we just learned, that 12.00 or 0.11 grams that carbon has is grams per mole, but it also turns out to be equal to atomic mass units, U. So we know that the atomic mass unit, or the atomic mass of hydrogen, is 1.0 roughly. It's actually 1.008 grams per mole. So in U's, it should be basically this many grams per atom. So what that tells us is that one atomic mass unit is 1.66054 grams. Or excuse me, I left off the times 10 to the negative 24th. And I think I left that off on the other side. Yes, I did. Times 10 to the negative 24. Okay, so that's what I got when I divided 1 gram by Avogadro's number. And that also has to equal 1 U. So I think you see that, in fact, if I wanted to convert this to kilograms, then I could say, let's multiply this by 1,000 grams on the bottom equals 1 kilogram on the top. And when I do that, I get 1.6605 times 10 to the negative 27th kilograms. So what we see is that 1 U is equal to 1.6605 times 10 to the negative 24 grams is equal to 1.6605 times 10 to the negative 27 kilograms, which is equal to 1 over Avogadro's number. That's the key point. In other words, I never took the time to memorize 1.6605 times 10 to the negative 27th, because I knew from this argument that the answer is that 1 atomic mass unit is 1 over Avogadro's number. Okay. And now that you have that, you now know that the periodic table grams per mole and atomic mass units per atom. Okay. So that's the big thing that I wanted you to learn this time. I didn't get as far as I'd like, but it is 6:40. Class is technically over. I'm lucky I got through this much because I thought the bandwidth was going to go to crap because we're having a bad storm here. But I think that's enough right now. I will finish the rest next time. And of course, you guys are free to go. But I want you to remember, now that you have that, you can do cool things. Like you can say, okay, if I look up the density of aluminum, then that's the number of milligrams or grams or kilograms per volume per cubic meter or something like that. And if I look up the molecular weight, which is represented by U's per atom, you can actually divide that by the number of atoms, and therefore you get the mass per atom. And that can actually allow you to figure out how far apart individual atoms are from one another, or individual molecules, if you use molecular weight, individual molecules are from one another, just by using the knowledge that basically one atomic mass unit is the mass of basically a hydrogen atom, or specifically when I look up the periodic table, the mass that they give me is always grams per mole or atomic mass units per uh, per atom. Okay, so we can do a lot of neat little things like estimating the distance between atoms and stuff like that. That's enough to get you started. I will mostly give you a lot of the equations outright for the rest of this chapter, as opposed to deriving them. There's not much point in deriving them, like length contraction, or excuse me, length expansion due to temperature and stuff like that. But we'll finish up chapter 17 next time. And chapter 17 is pretty straightforward. So even if I don't get to cover every little bit in it, there's plenty of my videos that I've given you links to catch any of it. So even if I don't cover all the material in chapter 17 today and next meeting, you will still be done with 17 this week, because you have access to all those. So everybody is free to go. Thank you for coming. And I will try to keep y'all posted when I post the syllabus and any other new stuff. But thanks everyone for coming. I will wait for the last person to leave in case anybody has any questions. So I'll do my Forrest Gump now. Okay. Excellent, Reynolds. I thought you were Hannah. I didn't think there was two Hannahs with that last name. So you're taking both of them simultaneously, huh? Okay. I actually just got it approved for one of my students doing that. Luckily, they let you without any approval. But yeah, you're going to get a lot of physics this semester. I hope you're not taking any other classes, or maybe just a nice, easy physical education like bowling or something, so you don't have to work too much outside of class, because that's a tough load. Good, good.
Hey, Professor Younger.
Yes.
I had a question. So, I didn't miss your first little talk about like the injuries, so you won't be driving to the school. I was one of the students last semester that asked if I could come to your morning lab instead of the one that's assigned tonight. So you're not gonna be here tomorrow, right?
That's correct. I'll be doing
okay.
an online lab.
Okay,
Actually,
gotcha.
send me an email right now, like really now, so I can remember,
Yeah,
and I'll send
right.
you I'll send you an invitation to the Zoom meeting,
Yeah,
so
the
you can
link.
attend tomorrow's lab.
Yeah, my friends in your mechanics class were telling me about how you guys were doing online lab.
Yeah, we're doing the same thing, and this first week's really an easy one to do online. Not only that, I'll probably spend some of the time using that time to actually cover some more chapter 17 material. What's your
Yeah,
first
cool.
name, by the way? I know it
Oh,
says
it's
ML.
Micah.
Oh, it's Micah.
Micah
Okay, gotcha.
Lee. Yeah.
I thought I
I was
recognized your voice.
yeah, I was in the same time last semester. Yeah, for your
Gotcha.
mechanics class, yeah.
Good deal. Yeah, if you want to attend tomorrow, just send me an email. That way I'll know who to send it to, and I'll send you the invitation for that lab tomorrow so you can attend it. Because if you're not in that actual class, you don't have access to that actual Canvas page, which is where I posted it. Getting a spam again. So I'll do that for you, Micah. Thanks for letting me know. And yeah, like I said, if you want to attend one of the face-to-face ones, I even have a couple students asking me if they get too confused, could they maybe attend a day lecture every now and then? And
Okay.
that's not a problem. You guys are enrolled in my class, so I know you're safe from a TB standpoint and all the other vaccination crap that they want you to do. So I don't mind you coming in, because our classes have a lot more seating capacity than we actually use to fill a class. We normally cap our classes off at 24 when a lot of our classrooms can hold 84 students.
All right, I sent you an email on Canvas just to get that out, and then I'm gonna send one through the
Okay.
Gmail.
Let me address that too. I never check that Canvas email.
Okay.
Like I literally, I've never ever checked it. So don't send those anymore.
Oh,
It
okay.
doesn't matter if you do send me one. I just probably won't see it. But yeah, if you send it the other way, that'd be great.
Yeah, sorry, I'm saying, well, I'm like young, so I've never had to send an email,
Gotcha.
not
Well,
regularly. So it's like
you might even be
having
able
a
to
brain fart.
send the email that I sent you with the I
Oh
think I sent it.
yeah, I gotta go
Yeah.
back up in the chat. Yeah.
You might be able to reply to that one. It'll be fine. Okay. Also remember, guys, when you do reply, you normally have to erase or at least move part of the subject line so you can start it with the appropriate subject. But I think you're good to go other than that. Any other questions, Micah?
No, that's it. Thanks.
All
Yeah,
right.
I'm just gonna send this.
Thanks. Appreciate that. How about you, Logan and Hannah? Do y'all have any questions?
Yeah, so your lab tomorrow is virtual,
Yeah,
right?
and it probably will be next week too, just because of my shoulder surgery situation.
Okay.
Uh,
Yeah, so I should get the link anyway because I'm enrolled in that class, right?
yeah, but that's the problem. You're enrolled in the Eastern Shore thing, so I'm gonna send you an email with that, but and just in case they don't get you switched to my regular one, because like I said, it's a lot of work for me to put the stuff into a Canvas course for a full online course. That's why
Yeah,
I'm
no, I
trying to put my foot
understand.
down and make them put you in there. But even if they
Yeah,
don't, that's not your issue. I'll work with you. But I'm gonna go ahead and email you that too, since I already have an email from you.
All right, yeah, I
okay.
sent you the email. Also, I guess I have to talk to Miss R about it as well.
Yeah,
Really
she needs to
like that.
approve it as well. So make
Oh,
sure you
okay,
ask her.
yeah,
I'm okay with it, but you need to ask her too.
yeah, that's right. All right, I got you. All right,
All
thanks,
right,
Mr. Younger.
no problem. Have a
See
good
you
one.
later.
How about you, Hannah? You wanting to do the same thing?
I just had that question about the mastering for 241.
Mm-hmm.
I can't find the course ID.
Okay, so that sounds like you're probably attempting to go to MyLab and mastering from the internet instead of from
Through
Canvas.
Canvas. Through Canvas.
Oh, really? So it shouldn't be asking you for that at all. Let me share my screen for a second. I'm going to first off put it over here.
Yeah.
Okay, so I'm going
Um,
to share screen. I'll share
or I
that one.
don't know if it's possible, like if I have to buy the like the set over again for the physics 1, or
No,
if I can just
well,
add the
actually, did you use this textbook somewhere else before?
No,
Okay.
I have not. So
Okay.
I just got the 1 semester.
Okay. And
Okay.
that probably works. Let me, so if you look right now at my Canvas module,
Uh-huh.
what you should do is go down here and hit chapter 17 for this one, or you
Yeah.
can do it in your 241 class.
I have it all set up for this class for 242.
Uh-huh.
So it's just for 241.
Okay, well let's go to your 241 class then, and I'll see what you're looking at. That might help me a little bit more.
Thank you.
No problem. Yeah, I've been explicitly told never give my course ID because it could make it where it's impossible for me to get your grades. And that's sort of the beauty of doing this is I don't have to. And you were in my 241 night class
Right,
as
right.
well. So, all right.
Yep.
All right. So I'm pulling this up. Now I'm going to go to the first one. I'll click on chapter 1 homework.
Okay. So it might have been because I was using the Pearson link.
Yeah, but this is weird. It should have fixed this already.
Okay.
Okay, well, let me redo this process again. So this might have been your problem. I set it up yesterday, but it's acting like it doesn't know anything about it. So I'm going to go set it up again. You can watch me. It's nothing, bad or anything. I don't think it even shows my email or anything like that. So this is the course I'm copying, which is from last semester.
Mhm.
And this is University Physics 1. And the start date is going to be there, and the end date is going to be. Actually, yeah, I've been consistently doing that, so I'm trying to keep it off. So the 15th is when this first one's due. Now I'll create course. So that might have been what the problem is. And they'll say this could take up to 6 hours to create. I've usually found it done within an hour. So try clicking back there in an hour. And if you don't get it, text me because this is sort of a real time thing. So it'd be okay to text me.
All right.
Did you get my number copied down, or do you want me to chat it to you? Okay. All right. Thanks, Anna. Have a good one.
You too. Thank you.
Bye-bye.
Bye.